Hi guys, so this is some additional equilibrium constant practice. So let's take a look at this problem. For a synthesis of hydrofluoric acid from hydrogen and fluorine, we need 3 moles of hydrogen gas and 6 moles of fluorine gas mixed in a 3-liter flask. The equilibrium constant at this temperature is 1.15 times 10 to the 2. Calculate the equilibrium concentration of all the components. Pause, attempt the problem, and then come back and see the answer. Okay, so I have written what we know. We have our formula. We have our initial concentrations of, we have 3 moles of hydrogen and 6 moles of fluorine mixed in a 3-liter flask. So our concentrations are going to be 3 moles over 3 liters, right? And 6 moles over 3 liters. And initially we're saying that we have no product. So we know our Q. So let's take a look at our Q. Our Q rate is going to be our initial concentration is 0 here. So we already know where this is going, right? But we'll write it out anyway. And we've got 3 divided by 3, so that's 1. And we got 6 divided by 3, so that's 2. But we know that all of this is going to equal 0. So our Q equals 0. We know that our K equals 115. So K is greater than Q. So that means that we have more reactant than product, and that we are going to shift towards the right, that we need to make more product. So that means that these guys are going to decrease. Our change is going to be decreasing. And this guy is going to increase. By how much? Well, remember I'm going to grab my red pen here. We take our coefficients and we put those numbers down there, right? So that means that this guy is 1x. This is 1x, and this is 2x. So our change is going to be 1 minus 1x, 2 minus 1x, and obviously it's 0, so plus 2x. So now we are going to fill that in. So we've got 2x squared. And we've got 1 minus 1x, no exponent. And 2 minus 1x, no exponent, equals 115. So we need to figure out x, which when we pop that into our calculator, we see that x equals 2.905. And we're going to put that back into these numbers. And so I'm going to grab my different color here. So we're going to put that back into there. And let's see. We get our hydrogen gas concentration is 0.0315 molar, and our fluorine is 1.03 molar, and our hydrofluoric acid is 1.94. And so these 3 actually are the answer to our question. I don't like how that arrow only goes to 1. You're going to do it for all of them. Okay? So there we go. So that's how we answer that guy. All right, let's look at another one. For the following reaction, we have hydrogen gas and iodine gas, and they are synthesizing to produce iodic acid. And we have a Kp, because we're in gas, so we have our pressure, our equilibrium pressure of 100, basically. So we've got our iodic acid at 5 times negative 1, so 0.5 atmospheres of pressure. Our hydrogen gas is at 0.001 atmospheres of pressure, and our iodine is at 5 times 10 to the negative 3 atmospheres of pressure, and they're all mixed in a 5-liter flask. Calculate the equilibrium pressures of all the components. So go ahead and pause this and answer that question. Okay, so here we have a new problem. Go ahead and pause this and answer the question, and then come back and we'll talk about it. Okay, so let's take a look. So I've written here our equation, and everything is a gas, so we can include everything. And we have our pressures here. So remember that when we're talking about Kp, we're not talking about concentration, so we don't need to divide by the volume. We're talking about pressure. So all of these were given in pressure. So our Kp is going to be the pressure of Hi to exponent over the pressure of H2, no exponent, times the pressure of I2, and no exponent because they both have a coefficient of 1. And we were told that Kp is actually 100. Making sure I remember that correctly. So it equals 100 right there. All right, we need to figure out Q so that we know, are we adding or subtracting our reactants? Are we adding or subtracting our products? And so for this guy, we're just going to take 0.5 and square it, and 0.01, that wasn't a good decimal, and 0.005. And our Q equals 10,000. That's a big number. So we can see here that our Q is bigger than our K. So that means that we are shifting to the left. We have more product than we do reactant. So we are going to subtract from that guy, and we're going to add to these guys by how much? Right, 1x, 1x, and 2x, right? We grab those numbers from our coefficients there. So at equilibrium, we've got 0.01 plus 1x and 0.005 at plus 1x and 0.5 minus 2x. And so we're going to plug these numbers here into this formula and solve for x. And when we do that, we see that x equals 0.035. And then we're going to take x and we're going to put it back into these guys to come up with our final concentrations. And I'm going to write that up here because I've kind of run out of room. And so we see at equilibrium, the concentration of, the pressure of hydrogen gas is going to be 0.046. Whoops, and I got to change this to be parentheses because it is not concentration, it is pressure. And the pressure of iodine is 0.041 atmospheres. We are in atmospheres. And our pressure at equilibrium of this guy is 0.43. And that all of those answers are in atmospheres. You should write the units each time. I've run out of room up there, so I'm kind of cheating a little bit. All right. How'd that go for you? Good? I hope so.